Yeah. Our next lesson class is entitled acidimetry. This is a type of neutralization reaction, but this one is still about titration. Okay, so again, this one is still about titration. Now, let's define first what acidimetry is. When you say acidimetry, ganon. Okay, sorry for the interruption again. We have first acidimetry. When you say acidimetry, we are going to do titration to standardize or to determine the concentration of our basic substance using an acid. Okay, using an acid. Please remember, pag acidimetry, nagtatitrate pa rin tayo. Okay, either direct or residual. Other name for residual is indirect titration. As long as it is titration, and our purpose for doing titration is to determine the concentration of a base, okay, of a basic substance. So therefore, our analyte here for acidimetry is a base, and our titrant is an acid. But this is called again acidimetry. So this is referring to the titrant being used. The titrant class, diba, is the one that is added using a burette. Therefore, the basic substance will be in the Erlenmeyer flask together with the indicator during the titration process. But we had defined this one last meeting, but let me just repeat it. Since acidimetry, we can do either direct titration or residual titration. Now, when you say direct titration, we only have one sample or one analyte and also one volumetric titration or one titrant. Volumetric solution pala. So for acidimetry class, when you say direct titration acidimetry, your sample here is a basic substance and you only have one titrant, and that is a base. So direct siya. Direct ginagawa yung titration. However, there are also instances that we will be doing residual titration, otherwise known as the back titration. So we use this one. We do residual titration if, for example, the direct titration is not possible because we cannot obtain a sharp and distinct endpoint. Meaning, even if we add an indicator and we have followed the correct procedure, the reaction will be slow. And if not slow, we will not really get a change in the color of the solution that will signify the end of the titration process. So again, that is the reason why we do indirect or residual titration. That is, again, because the reaction can be slow. The analyte or the compounds being titrated do not react quickly. And pwede ding the analyte has poor solubility. For example, the analyte is powder, and before we can do titration, we have to dissolve it in a solvent. Now, if it has a poor solubility, then we will have a problem during titration. The reaction will become slow also. And at the same time, if the analyte is volatile, meaning it will evaporate easily, especially if we are just conducting the titration process in a normal environment, like room temperature lang siya. So mag-volatilize siya. So therefore, we cannot really do the direct titration. So how do we do the indirect or the residual titration? You have there the sample. Again, pag acidimetry, always yan siya, the sample is a base. Kasi our next lesson for next meeting will be alkalimetry. So dalawa kasi ito sila. Pero this time acidimetry muna. Do not forget that always pag sinabing acidimetry, the sample will be a basic or an alkaline substance. But since this one is a residual titration, then what we are going to do is to add an acid in excess to the sample. That's the first titrant. Now, after adding the excess or excess na acid to our sample, we will do titration with a standard base. And the standard base will now become the second titrant. So that's the difference between direct and indirect. Direct, one sample, one titrant. Now indirect or residual, one sample, two titrants. But for acidimetry, the sample is a base, the first titrant is an acid, and then the second titrant is another base. That's a different one, it's a different basic substance, different from the sample. Okay, now there are also instances that we do blank titration. So remember, we had defined this one last meeting also, that there are times that we repeat the whole procedure from the weighing with the titration process, but we are going to omit the sample. That's again blank titration. Now we do this just to check whether there are biases or variations na nangyari during the actual titration process with the sample. Baka may contamination or whatever, may something wrong with the procedure, and we can easily compare it with the result of the blank titration. Okay, any question so far? These are just things that you need to know, mga terms that we need to define about acidimetry. Questions? Wala. Sure na. Sure na, Gerd. Sige, so kung wala ay walay question, sig natulog na mo ha. Sig natulog na mo na after sa quiz, natulog na ni sila. Manong wala katigig. Let's have first class computation of normality before I will introduce to you another set of problem solving involved in acidimetry. Ito yung computation ng normality. Actually, we are done with this one, right? I have given you this. Actually, this is also included in your prelim exam. This is our formula for normality. This is N is equal to weight of the substance, that should be in grams, divided by, if the volume is in ml, you have to multiply it sa milli-equivalent weight. But if the given volume is in liquid, then you have to multiply it with the equivalent weight. Let's have our participation first, our recitation time. Since we are done with this, let's just have a short activity with normality before we'll move on to percent purity. So get a clean sheet of paper there, or an extra sheet of paper only, and then please solve for the first problem. And then send your answer, direct message ha, do not send it to everyone. Send it directly sa akin, ang answer ninyo, so that I can record it for your recitation. Sige, I'll give you time to answer the first problem. No need to copy and answer. The final answer. 2 decimal places. Yeah. 2 decimal paki-round off. Uy, hilahi mo answer. Paki-check daw. Kita ka tama ninyo. Okay, let's check. Ay, where is my pen? Wait, let me get my pen first. Zero point zero one. 0.01. Okay, let's see. So what are the given here in our problem? You have y, oh, y. Send lagi sa ako ang messenger mo kung kinsay nag-chat. Diri lang sa ano ang answer. I-send. Okay. Sige, sulat na. Yan, sulat na siya. Okay, so here are the given. We have here the compound is sulfuric acid And then the amount of sulfuric acid used is 0.35 grams. And then the volume of the solution, I don't need to send the picture, is 500 ml. So since this is 500 ml, we will automatically use this formula. Okay, so we have the weight of the substance 0.35 grams. The volume in ml is 500 ml. And we just need to compute for the milli equivalent weight. So this is the weight, molar mass. This one is the molar mass divided by F times 1,000. So the molar mass, this is H2SO4, hydrogen, sulfur, and oxygen. 2 hydrogen, 1 sulfur, 4 oxygen, times their respective atomic weights. Again, let's just use whole number para similar tayo lahat. This is 1. This is 32. Please check if this is really 32. Kasi nagpataka lang. I don't have access to sa table ngayon. 16 times 4 is, wala na sa akong pen. Naluag ko ang sa kanan. Ulit. Ano naman siya? Ayan. Okay. So this is 16 times 4. Yes, 16 times 4 is 64. So this is 64 plus 32 is 98. So our molar mass here is 98 grams per mole. And our F, since this is an acid, so we will be looking at the number of replaceable hydrogen. And for sulfuric acid, that is 2. 2 times 1,000 milli-equivalent per mole. Cancel the mole. This is 98 divided by 2,000. It's 0.049 grams per milli equivalent. So again, this is 0.049 grams per milli equivalent. Cancel the grams. This is 0.35 divided by 500 times 0.049. This is 24.5 ml per MEQ. When we divide this, we will be getting the reciprocal of the unit. So 0.35 divided by 24.5 is like 2 decimal places na, so 0.01. Again, let's get the reciprocal, milli-equivalent per ml, or simply 0.01 and then capital letter N. So for this solution of the sulfuric acid, again, the concentration is 0.01 N. You have already your face-to-face laboratory class sa QC. Tapos na ba? Or wala pa?
Ngayong Monday
Wala
pa,
pa, ma'am.
Okay. Sige. I think you will be doing titration also. Okay, next. Everything is recorded, ha? Kung nag-send mo sa chat box kung answer ninyo, that will be credited as your recitation. So let's have number 2. This is still computation of normality. Pause ni. Just say, sige. Let's wait for the others. I-share sa inyo yung answer mo, ano, di mo parehas ang answer. Ayaw sa discuss. Ano? Nga naman. Pangunsa day ka. Wala tanda na to siya. Wala sa mo class. Yeah, to decimal places. Ay, sorry. Nasolve pa ka. Abi na ako gawin sa Okay. Okay na. Pwede na ito mag-solve. The same formula. Ay, no. Kasi liters pala yung given. So pag liters ang given, di ba, our formula is weight still in grams, but again, the volume is in liters, and we will be using the equivalent weight. So the weight in grams given here is 2.5 grams, liters 0.74, times the equivalent weight. For the equivalent weight, this is the molar mass divided by the F only. So the molar mass, this one is sodium hydroxide. So sodium 0 and 0. Oxygen. Oxygen and hydrogen. 1, 1, 1 for each. So NaOH ito. This is 23, 16, and 1. So 23, 16, 1. This one is 40. 40 grams per mole divided by the F. So this one is a base. Therefore, we will be using the number of replaceable hydroxide. And for sodium hydroxide, that's just one only. And then our unit here is equivalent per mole. Cancel the mole, you will have 40 grams per equivalent. So we will use this one here. This is, let's cancel the grams. So 2.5 grams divided by 0.746 times 40 is 29.84 liters per equivalent. Let's divide 2.5 divided by 29.84. Round off 2 decimal places, that's 0.08, and then let's get the reciprocal. The reciprocal of this, equivalent per liter, or 0.08, and then capital letter N. Okay? So what happened doon sa hindi 0.08 ang answer? Namali ang formula. Ako lagi kayo ng isa. Ano na? I think you used nearly equivalent weight instead of the equivalent weight. Saan galing ang 0.11? What happened with the 0.09? Ano ginawa niyo dyan? 0.08 man talaga.
Ay, ako anak, ma'am, kay mali day ang weight ko sa sodium, ma'am. 23 day, 22 ako.
Okay. That's 23. Yes, a molecular weight. Okay. What should you do with the atomic weights? You round it off to the nearest whole number, ha? Nearest whole number. So, like sa sodium, that should be 23. Sa oxygen, I think ang nakalagay sa periodic table is 15.99. So, since nearest whole number tayo, then that is 16. Okay? So, again, the answer is 0.08. Next. Sa unit una. Oo, yeah. Pag sinabi niyong pag normality class, this is equivalent to either MEQ per ml or EQ per liter. Okay? That's the conversion. Next. Sige, next. Another one. Practice makes perfect. Charog. Direct message yapon ha. Lalahi mo mag-answer class. Wala pa yung nagkapareho answer so far. Ano man na? Okay. Sige. Mana? Wala na yung maghabol. Let's have this problem. So in here, we will not be looking for the normality. Instead, the amount of the substance or the weight of the substance in grams. So we have here the following given, 345 ml for the volume, and then the normality is already given, 0.9871 normal calcium hydroxide. Now, since this is an ml, we will be using the formula, this one. The volume should be an ml, and then we will be using the milli equivalent weight. Now, I think I have already told you that if you are not that used to deriving formula, just use the original one and just go with the flow for the solution. Like this one, I will just substitute 0.9871 for the normality. Instead of capital letter N, I'll just use MEQ per ml so that I can freely cancel the units later. Now we have here the weight, the weight of the substance. This is what we are looking for. And then sa baba, we have the volume, the 345 ml. And then for the milli equivalent weight, we can compute for this. The substance is calcium hydroxide. This is our chemical formula for calcium hydroxide. Paano yan siya naging CaHO2? Ca is positive 2. Look at your periodic table. Calcium belongs to the group 2. And then hydroxide is a polyatomic ion with a charge of -1. Now, if you add these two, you will not get 0. Therefore, you have to do crisscross. And that means when we do crisscross, calcium will take 1 from the hydroxide, but you don't need to place 1 here. But the hydroxide will take the 2 from calcium and it will become its subscript. Now, since we are sure with the chemical formula, we can proceed in the computation of the molar mass. You have 1 calcium, 2 oxygen. You have to distribute 2 for both elements, and then you also have 2 for hydrogen. So for calcium, this is 40, 16, and 1. So this is 40, this is 32, and this is 2. So this one, if let me check. This one is 74 grams per mole. We can proceed also with the computation of the milli equivalent weight. This is 74 grams per mole divided by, this one is a base and we have 2 hydroxides here. Therefore, the equivalence factor or the F is 2 times 1,000. And then this is milli equivalent per mole. Cancel the mole. You will be left with grams per milli equivalent. So this is 74 divided by 2,000 is 0.037 grams per milli equivalent. We will use this one here, 0.037 grams per milli equivalent. Before I proceed with the multiplication, I can actually do crisscross here. And that means we can place the weight here on the other side. And on the other side, we can multiply everything. 0.9871 MEQ per ml times 345 ml times 0.037 grams per milli equivalent. So we can cancel the ml. The other one is in the bottom, the other one is on top. And then we have MEQ also. We can cancel this. And then we will be left with the unit grams. So 0.9871 times 345 times 0.037 is 12.60. So this one is the correct answer. We need 12.60 grams of calcium hydroxide to be dissolved in 345 ml solution to get this concentration. But again, the answer is 12.60. So what happened to those who were not able to get the 12.60? Some of you answered 13. I think you rounded this off to the nearest whole number. That's okay. But during quizzes and exam, you really have to read and follow the instructions, okay? How about the 13.62? 12.43. So yan sila. Ay, sorry. Siya pinitingog. 11.43. Okay, be careful during the process. You might have missed something from the given or from the equation itself. I will pag-round off. Do not round off during the process. Okay? Always do the rounding off for the final answer only. So kahit pa mahaba masyado yung answer dyan, for example, in the milli equivalent weight, please include all of them. Wala na times 2 ang oxygen. Wala siyang ginaingon na be careful. Okay? Sige. Wait. Asa na to? Last one before we'll move on sa percent purity. Last one. Ay, done na ito? Ay, this one. Ay, parehas lang sila. Ay, this one is the last one. Okay. Sorry. Muna ni know what is the weight mo na itong bagulang dissolve. Last one na pala ito. So we will move on na pala sa percent purity. What time is it? It's 3 o'clock. Okay. Sige. When you say titration, I told you right that our goal is for the standardization of our chemical substances. When you say standardization, we are determining the concentration of these chemical substances. But aside from that, class, the titration process can also be used to determine the purity of our chemicals. So kung pure ba sila or if there are contaminants, we can identify that one using titration. And in this case, we have here the equation for direct acidimetry. Okay, so when you say direct, we only have one sample and we also have one analyte. And since this is acidimetry, then the sample is a basic substance or an alkaline substance. So please copy, take note of the formula for the percent purity for direct titration. So percent purity is equal to the normality times the volume. This should be in ml ha, kasi the partner is in milli equivalent weight, divided by the weight of the sample times 100. So we don't have a unit here since this is in percent. We will just look at how pure your sample is. So it can be 100% pure or maybe less than that. But again, the process to be used here is still the titration process. Okay, please copy this one. Now let's move on directly to the problem solving. Problem solving dayon ta. We have here on the screen a 45 grams sample of sodium bicarbonate, or this is what we usually call as the baking soda. The molecular weight is 84.01. Though we can use 84 para uniform tayong lahat, pwede din 84. Let's round it off to the nearest whole number na lang. Okay, during the titration process, this 45 grams sample of the sodium bicarb consumed 24.50 ml of 1 normal sulfuric acid volumetric solution. VS is volumetric solution. Now the question is, determine the percent purity of our sample. Again, this one is acidimetry because take note, our sample is sodium bicarb. And this one is a direct titration process. Sorry, ma-distract ko sa mga nagatingog sa world. This is a direct titration because we only have one titrant, and that is an acid, sulfuric acid. So during the process, the concentration of the sulfuric acid used is 1 normal, and the volume na nagamit during titration, this can be measured using the burette. It's 24.50 ml. The question is, what is the percent purity of our sodium bicarb? Okay, VS is volumetric solution. Wait lang. Walang ito pa doon. This is urgent. Okay. Sige. So what was our formula again? Percent purity. Just write P ha. Percent purity is equal to normality times volume in ml times milli-equivalent weight divided by the weight of the sample. This should be in grams times 100. We are looking for the percent purity, so definitely the normality is given. That's 1N. Let me just use MEQ per ml so that I can cancel the unit. So if I use normality, we will be confused later on. How are we going to cancel the other units? Anyway, 1N is equivalent to 1 MEQ per ml. So let me just use MEQ per ml here. And then the volume should be in ml. This is 24.50 ml times the milli-equivalent weight. It's not given in the problem. Again, it's not given in the problem, so let us compute for that later. And then the weight of the sample. So again, this is for the sample here, 45 grams of the sodium bicarb. Now question, we have two compounds here, sulfuric acid and also the sodium bicarbonate. So what do you think are we going to use for the milli-equivalent weight? Sulfuric acid ba o sodium bicarb? Kaya mostly diri na maglibog ang mga estudyante. Okay, very good. We will be using sodium bicarb because that is the sample. Again, that is the sample. Kung ano yung compound na ito, yung weight of the sample here, that should also be the one that we are going to use for the milli-equivalent weight. Now, since this 45 grams is referring into the amount of the sodium bicarb, then we will be using the MEQ weight of the sodium bicarb. So, sodium bicarb, we don't need to compute for the molecular weight. It's already given in the problem. We just need to compute for the milli-equivalent weight. And then let's just use 84. 84 grams per mole divided by, what do you think will be the F for our sodium bicarbonate? This is not an acid. This is a base though, but we don't see any hydroxide here. So this can be a salt. We can call this a salt. What is the F here? Sodium is positive 1. Bicarbonate is a polyatomic ion with a charge of negative 1. So definitely this is 1. Okay. The equivalence factor for sodium bicarb is 1 times 1,000. And then our unit MEQ per mole. You cancel the mole. So this is 84 divided by 1,000. It's 0.084 grams per milli equivalent. So we have now here 0.084 grams per milli equivalent times 100. So let me just write the continuation here. Let us cancel the units. We can cancel the MEQ, we can cancel the grams, and we can even cancel the ml. So again, I told you a while ago, we don't have a unit here. It's just in percent. So 1 times 24.5 times 0.084 is 2.058 divided by 45 times 100. So 2.058 divided by 45 times 100, the answer here is 4.57%. So this is class, the percent purity of our sample, which is sodium bicarbonate. It's only 4.57% pure. I think I had a student just this week who asked me na, ma'am, paano nimo mabalaan, ma'am, kung pure ang imuhang chemical? Kaya we were talking about contamination or contaminants. And then I told them, we can always perform a lot of experimental procedure just to check whether our substance is pure or not. And one of that is through titration. And this is the example. You have there a sample of a sodium bicarb. We performed, like in this case, they performed titration using sulfuric acid, and then using the values or the data obtained in titration, we can compute for the percent purity. That's 4.57% for sodium bicarb. Okay? Ano yung range na masabi na pure ang substance? Pag 100% siya, pure yun na siya. Pero I don't think we have substance. Minsan may lumalagpas ng 100%. That's okay though. Kung sobra talaga, excess talaga. Meron akong na-try na paracetamol tablet, not paracetamol tablet. Sodium bicarb tablet pa rin. 'Di ba meron tayong sodium bicarb na tablet ginagamit as antacid. So kapag ang labeled amount niya is, for example, 300, ilang labeled amount ng sodium bicarb, I'm not sure anymore. But for example lang, 300 milligrams. Pag nagsobra kasi ng 300 milligrams yung content ng tablet, that's the time during titration, you can get more than 100% purity. But nevertheless, it's pure kasi sumobra siya. Ang ideal is 100%, but even pure primary standard, ang kanilang target lang is at least 99.9%. Okay, but nevertheless, ang uban kung babaan na, that will not be considered pure. And that is the reason why we have the so-called USPNF, United States Pharmacopoeia and National Formulary. It contains a list of chemicals or even drug products, and nandoon class ang standard and specifications. Lahi-lahi man gud na sila og standards and specifications. For example, sodium bicarb tablet. If we do titration of that and compute for the percent purity, I think the standard and specification is 80 to 100, 90 to 110%. As long as during the titration process, you get these values between 90 to 110%, papasayan siya class sa standard and papasayan siya sa standard ni FDA. Kasi since like mga USPNF pa rin naman yung kanilang reference. But if you have a drug product and then pag titrate ninyo, nag 50% na lang ang percent purity, yan, hindi na talaga yan siya matatanggap. And hindi mo na siya pwedeng ibenta. Kasi again, in terms of purity, hindi ka na sure. Pwedeng nag-degrade na yung ibang active ingredient, that is why naging 50% na lang or naging 30%. Sa pharmacy, yung ating goal talaga is at least 90% pataas para matawag siyang pure substance. Wala. Ma'am, nga nung sodium bicarb. Nga nung sodium bicarb ang gigamit because that is our sample class. Yan yung ating kinukuhanan ng percent purity. The sulfuric acid is just there as secondary standard. We just use that for titration. So, muna siya ang answer. Anong sodium bicarb? Posible na 2 or 3 ang unknown sa problem. Like need mo i-solve muna before ang purity. Most of the time, what is lacking in the problem is the milli-equivalent weight. So yan lang yung mostly. And then meron ding times na hindi naman siya lacking, the volume is still there, but lahi nga unit. So ana lang ang mga cases, you just need to convert. Pero most of the time, milli-equivalent weight dyan ang wala. Minsan, binibigay ang molar mass, but most of the time, you have to compute first for the molar mass before you can determine the milli-equivalent weight. Okay? Questions? Ito yung ginagawa class sa QC. Yeah, possible. Possible class na baliktad, no? Di ba natin mga problems for normality na the weight is like unknown and you have to compute for the unknown, the weight or the volume. Ganyan din sa percent purity. There are times na percent purity can be given and what is asked in the problem may be the volume, the normality, the milli-equivalent weight, or even the weight of the sample. So depende lang siya sa problem. Okay? Anything else? Let's have another one. Let's see, kayo naman kung nasundan niyo ba yung ginawa ko kanina. Yan. Sige. This is still sodium bicarb. Since this is acidimetry, so you expect that our sample is really a basic or an alkaline substance. Spasa di just yung answer. Let's see. Basing mali. Sige, let's see later. Let's wait for them. So, wala na? Sige. Let's check. Okay. Naiuban lahi pag ang answer. The same formula, class. The same formula. Percent purity is equal to N times B times milli-equivalent weight divided by weight of the sample times 100. the problem still looks for the percent purity. Therefore, normality is given. That's still 1N. So 1 MEQ per ml times volume. The volume is just 15 ml times the milli-equivalent weight. Since this one is the same compound, diretso na tayo for the milli-equivalent weight. Diba? The molar mass is 84 grams per mole. The equivalence factor is 1. This is MEQ per mole. Ayan. And this is 0.084 grams per MEQ. So we will use that one here, 0.084 grams per MEQ. And then weight of the sample, our sample is sodium bicarb, that's 25 grams times 100. Cancel the ml, even the grams, and the MEQ. So 1 times 15 times 0.084 is 1.26 divided by 25 times 100. Dito na ako mag-continue. 1.26 divided by 25 times 100 is 5.04%. So ito lang yung percent purity of our sample, the sodium bicarb, 5.04. So what happened to those who did not get the 5.04? Anyari? Anong nangyari? So which part of the process yung may problem? This is completely 5.04. Again, do not round off during the process, ha. Doon lang tayo sa final answer. Maglibog jud ka sa pagkuha sa F. Okay, wait lang. Can I delete the writings in the screen now? Para mag-discuss ta og F. Yeah, 5.04% siya. If the F is, the MEQ weight is 0.084. Let's delete the writings on the screen. Okay, so for the F class, again, let's have a review. For the equivalence factor, you just have to identify what is the compound. I mean, what type of compound is the sample. If it is an acid, you just have to identify the number of replaceable hydrogen. Replaceable hydrogen. So like in the case of hydrochloric acid, since you only have one hydrogen there, then that is 1. For the case of sulfuric acid, you have 2 hydrogen, so automatically this is 2. For phosphoric acid, this is H3PO4. You have 3 hydrogen, and that means that the equivalence factor is also 3. Now, if your substance is a base, and when I talk about the base, I'm talking about those basic substances with an OH. Kasi yun din yung bibilangin natin. Number of replaceable OH. Though you know, class, that sodium bicarb is a basic substance, but since wala siyang OH, then we will not use this one. This is just true for the case of like sodium hydroxide. Since you have 1 hydroxide there, the F is 1. And then, okay lang sa Hershey. Pero magbago na yung answer. But that's okay. Just have to follow my instruction, like when I say sa quiz or sa exam na everything should be rounded off to the nearest whole number, then you use whole number for the molar mass. Okay? Now, ano na ngayon? Another example, we have the calcium hydroxide, CaOH2. You have 2 as a subscript for hydroxide, then That means you have 2 hydroxide. So automatic the F is also 2. For aluminum hydroxide, this one is 3. Now all the other compounds that cannot be grouped into an acid or a base, then we call them salt. Salt natin sila ha. And we will be looking into the total number of positive or, take note of the word or, negative charge. So just like when you say sodium chloride, you look at the position of the elements in the periodic table that will be their charge. Sodium belongs to group 1, so this is positive 1. Chlorine belongs to group 7, that's the halogens, and that for the halogens, their charge is negative 1. Or hindi mo siya i-add. Okay, parehas naman silang 1, therefore the F is 1. Take note of the word total. Bakit? In the case of aluminum oxide, you have their aluminum is positive 3. Nasa baba siya ni boron sa periodic table, so nasa group 3 siya. And then oxygen belongs to group 6 in the periodic table, and ang charge nito ay 2. In this case, hindi pantay yung charges, positive and negative charges. That's when we take note of the word total, meaning we need the subscript here. I-times natin sila. 2 times positive 3, that's positive 6. 3 times negative 2, that's negative 6. So kung kailan sila magpapantay, yun yung magiging F ninyo. So for aluminum oxide class, the equivalence factor is 6. You just have to get rid of the charge and just use the number. Okay, questions? Anyone? Anything else? For the case of sodium bicarb, this one can be grouped sa salt since wala siyang hydrogen, hindi siya acid, wala siyang OH, though basic siya. So you just have to look at the charge. This is positive 1. And then ito, bicarbonate ion ito. It's a polyatomic ion. There are periodic table na may nakalista na polyatomic ions, meron ding wala. You can make one, lagay nyo sa index cards. The polyatomic ions are not compounds. Compounds don't have charges. So ito polyatomic ion from the word poly, maraming atoms, and then ion siya. I mean, maraming atom and then ion meaning merong charge. So this one is negative 1. So that is why F is equal to 1. Okay? So I hope nagkasinabot na ta na. Okay na ta. So let's move on. Another example, but this time, anong hinahanap? The volume. You try daw. Kung walang parenthesis, yung last charge lang ang gamitin. What do you mean walang parenthesis? Last charge lang ang gamitin. Sabihin niya.
Ma'am, mag-onda ng kung...
Sige, go. Ano sabi ito?
Dara agad sana mo ka ng sodium bicarb ata, ma'am. Di ba wala sa parenthesis, ang gamiton na charge ay, ang gamiton is ning kaning 3 diri sa punta.
Di ba positive 1 ni siya? Kaning bicarb mango, this one is considered one entity. Okay? One entity ni siya. So, hindi nakahiwalay si oxygen dyan. Look at the list of the polyatomic ions. Since one entity sila, isang charge lang talaga yan silang lahat. Okay, again, isang charge lang silang lahat. Kaya, negative 1 ito automatically. So, hindi mo siya i-multiply na 3 times negative 1. No. Kasi si 3 is para kay oxygen lang. And then we are talking about the whole polyatomic ion. Gaya lang yan siya sa case ni sodium hydroxide. Sodium is positive 1. Hydroxide is negative 1. Though wala kang makitang subscript dyan, but this negative 1 is for the whole OH. For the whole OH, hindi mo siya isa-separate. Yan din ang case niyan ni HCO3. Okay? Pwede mo din tingnan like sodium nitrate. Sodium is positive 1. Nitrate is another example of a polyatomic ion and it's considered as 1. So again, we don't separate N and O. And if you look at the list for the polyatomic ions, this is -1 for the nitrate. So for the sodium nitrate, the equivalence factor is still 1 here. Again, don't multiply kasi the nitrate is considered as one moiety or one entity. This is only true for polyatomic ions, ha? Sa sodium carbonate is Na2CO3, right? This is different. This is sodium bicarb, sodium, and then HCO3 is called bicarbonate. Ito, sodium carbonate, sodium, and CO3 is the one called carbonate. Pero polyatomic ion pa rin siya. Ang gagawin for the sodium carbonate, sodium is still +1. And the carbonate, look at the list for the polyatomic ions. Carbonate is -2. It's for the whole entity. You don't need to multiply 3 and the 2. Kasi si 3 is para sa kay oxygen lang. Hindi siya para kay whole carbonate. So, ang final class na charge ni carbonate is still -2. But for the case of sodium, meron siyang subscript dito. So, 2 times 1, that's +2. Therefore, the F for sodium carbonate is 2. Okay. Anything else? Wala na. Sige, let's try this. If a 0.28 gram sample of sodium bicarb, the percent purity of the sodium bicarb is 96.5%. It's titrated with 0.9165 normal sulfuric acid. What volume of the acid should be required to produce an endpoint? So what is asked here in the problem is the volume. All the other things are given, well, except for the milli-equivalent weight, but you can always solve for that. Sige, you try daw and then we'll do the math later sa screen. Tinod, anak, Marvin. Sige. Nag-BTS naman. Pagamian lang ako ang ano para daghan kog space magsulat. Ay. Okay, let us start. O na to, tama ba na inyong answer ba? Dahil mo answer class. Gumaya sa 3.51. Wait, pero let's see. Like kung 3.51 after a little time, kumana ka sa imong titration. But let's use the same formula. Percent purity is equal to N times V times milli-equivalent weight divided by the weight of the sample times 100. Percent purity is given, that's 96.5. I will not make it as a decimal na format ha, kasi I will just use the 100 here. I-decimal mo lang siya pag kunin mo yung 100 dyan. But since I'll just use this para hindi ako ma-confuse, let's stick with the 96.5. And then the normality is 0.9165. I'll just use MEQ per ml. We are looking for the volume. And then for the milli-equivalent weight, what's the sample? Sodium bicarb pa rin. So this is still 84 grams per mole divided by F times 1,000, that's 1. MEQ per mole. Cancel the mole. This is 0.084 grams per milli-equivalent. So I'll write it here, 0.084 grams per milli-equivalent. And then the weight of the sample is 0.28 grams. I'll just include the times 100 here. So what am I going to do is like this. I'll stick with the 96.5 here. I'll cancel some units, MEQ, and then the grams. So I'll wait. I'll cancel the grams. Ayan. So 0.9165 times 0.084 times the 100 will have 7.6986. Ano nga naiwan na unit? Per ml. Per ml times the V. Naiwan yung V dyan. Okay? Divided by 0.28. So this is 96.5 equals 7.6986 per ml divided by 0.28 is 27.495 per ml times the volume. Now, we need to isolate the volume, so let's divide both sides with 27.495 per ml. 27.495 per ml. Therefore, the volume here, since nasa baba si per ml plus, we need to get the reciprocal. So, magiging ml na lang talaga siya. Hindi na siya per ml. Now, 96.5 divided by 27.49. Tama pala talaga. Tama. 3.51 ml. This is already rounded off. So again, the correct answer here is 3.51 ml. So tama. Tama man yun yung answer. Ang uban, wala nila nakuha ang 3.51. What happened? Cool ba kayo? Mali ang process. Sige, you can copy or you can, ingon sa ko mga, ingon nila, ito na. Nag-screenshot na lang mga estudyante, wala na nagka-copy. Pas-pas. Gimultiply ninyo so 100 as a whole. No? Ang 100, kasama yan siya dyan sa taas. Yung grams, yung nasa baba. I hope na sundan yun. Do we still have time? Yeah, we still have time. Let me delete the writings on the screen. Your internet connection is not stable. Sige, let's have another one. Do not forget the 100. This one is another kind of problem that might also be included in your board exam. We don't know. The disodium salt of dibasic organic acid has a molecular weight of 215. What weight of a sample would be used for titration to bromophenol blue endpoint with 0.25 normal acid in order that 35 ml of the latter be required? Again, in order that 35 ml of the latter be required. This one is not a percent purity na problem. This is just normality. Normality lang ito na problem. Una, you cannot see percent purity there. It's not asked, it's not given. But normality is given. 0.25 N na acid. The volume is given. And the molecular weight is given. All you need to do is to compute for the weight in grams. Sige daw, i-try daw ninyo. You try to understand the problem. And then, let's see if tama yung answer after. Wala pa? Dua pa lang ang nag-send. Tulo di ay. Naglibog ng uban. Oras na ganit. 4:18. Wala na. Again, I told you a while ago, this one is not a percent purity na problem. It's a normality na problem. So we will be using the formula weight divided by, what's the volume here? In ml. So the volume in ml times the milli-equivalent weight. What is asked here is the weight of the sample. So normality is given 0.25 MEQ per ml lang ha, kay para makancel. And then again, we are looking for the weight. And then, okay, again, the ml here is 35 times the milli-equivalent weight. So that is our problem now, the milli-equivalent weight. So diba, the milli-equivalent weight is the molar mass or the molecular weight molecular weight divided by F times 1,000. The molar mass is given, that's 215 grams per mole. And then the F here, mo na inyong problema, basig naglibog mo sa F ani. This is MEQ per mole. What is the F here? The F here class is 2. Even though hindi binigay what is really the specific compound, but take note of this, disodium, dalawa daw na sodium, and dibasic organic acid. So definitely you will expect na since disodium siya, if this is positive 1, 2 times positive 1 is positive 2. Even if you don't know what ano itong dibasic organic acid na ito, as long as you know that there is a disodium, positive 1 times 2, that's positive 2. So the F here is 2. So 215 divided by 2,000, cancel the mole. Our MEQ here class is 0.1075 grams per milli equivalent. So again, this is 0.01, ay, lagay 0, ulit. 0.1075 unit grams per MEQ. So we can do cross multiplication here. Baba natin si weight and then i-multiply na natin lahat. MEQ per ml times 35 ml times 0.1075 grams per MEQ. Cancel the ml, the MEQ, we will be left with grams. Since yan naman talagang hinahanap natin, 0.25 times 35 times 0.1075. The correct answer here is 0.94 grams. Okay, 0.94 grams. Oo, tama man. Tama man si Mervin ug si Charles. 0.94. Tama mo po ka, Shea. Okay? Asagi ka ni mo ang molecular weight day. Machine. Nakabutang man sa problem, it's 215. Yung problem lang talaga dyan is yung F. Okay? Questions? Before tayo mag-end. It's 4:23. Wala. Ano lang ang gawin nyo, class, ha? If the compound is not really given, you look for hints there in the problem. So just like this one, disodium. Diba, ibig sabihin ng disodium, dalawang sodium. So 2 times positive 1, that's 2. Therefore, the F is 2. Okay, kapihon mo. Sige, you copy. Recorded video sa research. Okay. Was not able to send the videos, no? Di si makadrain kayo ang face-to-face na klase ng good. Pag uli na ko diri sa balay, wala ko yung energy. Ako ganahan nag-open sa laptop. But later, i-upload ko. Naagihapon. Let's